next talk by Paul Tarau. He's going to tell us how to incorporate a logic language into Python.
Thank you. So let me start. Just checking that everyone sees my screen because I have about
yes.
3 of them.
Yeah.
Okay. Yes. Well, an organic diet for Python, devouring a logic-based language. That's a very healthy diet. And the motivation behind this is that there are deep family resemblances between Prolog and Python. There are surface differences, and the so-called programming paradigms make things much more antagonistic that they could be close deep down. We want to have a smooth embedding of logic programming language in Python, reusing as much as possible from Python. And the language is not log, also because it brings a little bit of more natural syntax than the one in Prolog, but deep down is just a Prolog system. The resulting symbiosis is, of course, mutually beneficial. Prolog benefits from the much wider Python ecosystem, and especially my current focus being on deep learning and neural net design and a lot of other things. That's a natural quick match for trying out things on the 2 sides. Prolog enables neurosymbolic inference and also deep learning system configuration. I will hint an example of that a bit later. Also, NatLog simplified syntax brings an easy to learn logic programming language to the machine learning practitioners. Here is the link to it, or nothing simpler for Python users, pip3 install NatLog, and it lands on your computer. Well, here's an illustration. There are some co-authors to acknowledge here. One, of course, is DALI 2, which is prompted by DALI painting of big Python devouring small NatLog. So here is Python, here is NatLog. And of course, the major acknowledgement is to DALI himself, to which DALI needs to acknowledge a very natural derivation. Let's look a little bit at the lightweight surface syntax. We want syntax to be as natural as possible, but not more natural, partly because COBOL and friends failed by trying to be natural at the wrong time and with the wrong tools. So here we have a sibling of XS, if parent of XP, parent of SP, and they should be distinct, otherwise you are your own sibling. And then nice transitive closure called ancestor of XA. It's either, that means it's a parent, and it could be a parent, or ancestor. And then parent or ancestor continues the transitive closure and finishes by calling recursively this one here. So I'm not using twice the call to parent as most people do in Prolog. Terms are represented as nested tuple. All Python data types are directly reflected. That's very useful. You don't need to create your classes just for Prolog and then spend time translating from one side to the other. Variables are the only exception to that. A variable is a boring little Python class with a single value slot, which by default is known, but it can follow references for unification and other purposes as in a standard Prolog implementation. We borrow memory management from Python, and we don't have no data to convert because we work directly with Python's underlying data structure. Nevertheless, NatLog is not slow. I didn't deliberately make it fast, but it has about 200-300 k logical inferences per second when we use it with this accelerator called PyPy that is a just-in-time compiler for Python. Some of the data exchanges, how they happen. Well, Python has a very nice generalization called callables, functions, classes, instances that define a call method. They are all callable, behave like functions, basically. So we have a minor annotation here. That's the length of a list borrowed, and this is the value returned, and the answer turns out to be a Python dictionary associating the name of the variable to the value. More interestingly, when you have generators, Guido expanded quite a bit on what they mean and where they are coming from in Python, like range here, a very simple example, with two quotes here, range from 1 to 4, bind the results to X, backtrack over them, return dictionaries for all values. If you have multiple values coming out, you will have a dictionary with all of them here. When natlog is called from Python, variable assignments are yielded as Python dictionary objects, as you can see here. Metaprogramming constructs, we have them on the two sides, and then we use setprop and getprop in natlog corresponding to, this is a procedure call, but procedure call meaning no value is returned. That's Python's built-in function set attribute, and this is getprop. So with this, you can do things like a method call. Let me read it for you, this one here. You have a method call on object O for a method F with a set of parameters X's here. You get the attribute called method. By the way, in Python, methods are attributes like everything else. And then you return the method M applied to all these arguments passed as a var arg to the method. So very much the elegance of Python reflected here, but with a very succinct notation in this Prolog dialect. This is an example how you make a stack, which is a procedural construct, but by mapping with method call to Python's dynamic arrays, well, called lists in Python. And the more interesting thing is now corroutening. Well, corroutening came up while in my mid-90s Prolog implementation had it already. A first-class logic engine is just a language processor reflected through an API that follows its computation to be controlled, that allows its computation to be controlled interactively from another logic engine. So very much like a programmer controlling Prolog's interactive loop, except that this time it's not the programmer, but it's the program that does it. So they actually are important because contrary to, let's say, negation as failure that reflects only success or failure of a Prolog engine, here we reflect the complete functionality of the Prolog interpreter. We don't borrow when we do meta interpretation backtracking from the underlying Prolog. We give the actual Prolog engine via a simple API to the user. So with that, we can do a very nice trick where we use Python's yield operation. We implement first-class logic engines by exposing the interpreter to itself as a Python coroutine that transfers its answers one at a time via Python's yield operation. So now, a few examples of programs that we can make here. Natlog can be used remotely as a Streamlit-based web app. Again, a few lines of Python do that. It's a very nice API for exposing Python applications on the internet. We use it as an orchestrator for JAX and PyTorch. JAX is, by the way, no destructive assignment there, a purely functional deep learning API, both on top of TensorFlow. PyTorch is object-oriented, but we can accommodate that quite easily. And here is an example that's a bit more relaxed. Natlog has definite clause grammars, which are a typical Prolog construct. And we can build 3D animations by using VPython. And with DCGs, here is a small application that, again, via DALI will be putting cats to play with a trumpet on the moon, and DALI draws it after we prompt it via the API with from Natlog based on the DCGs. Well, my conclusion here is that Natlog directly connects generators and backtracking, nested tuples and terms, reflection and meta-interpretation, and then coroutines and first-class logic engines. So the main, let's say, novelties in a way on the two sides, or things that not everyone has, but they both do have. This is the family resemblance between the two sides that allows us to have a nice symbiosis between the two. It enables logic-based language construct to access the full power of the Python ecosystem. There are links here to two papers that describe an initial sketch of Natlog and then a more elaborate one here. And an interesting thing just next in line, well, GPT-3 and especially ChatGPT, that's you might have probably seen them in the press. Some people are really afraid of those, which is a bit like being afraid of your own shadow. But anyway, that's a popular thing to be afraid of. Prompt engineering is a very interesting mechanism in which you can leverage those large language models and then combine them with a bit of logic reasoning and constraint solving and neural net post-processing that Natlog enables naturally. That's my talk. Thank you.
Thank you very much, Paul.